Hi everyone, we're going to verify a trig identity involving inverse trig functions. So we're going to show that this left-hand side equals the right-hand side. The first thing we're going to do is take our inner function here and let alpha equal inverse sine of v. And then for alpha, we're going to get sine of alpha equals v. So we can get rid of that inverse. So when we have that, let's do our restrictions. When you do the inverse like that, our restrictions is in quadrant 4 and quadrant 1. So from quadrant negative 90 to 90. All right. Now let's go ahead and use substitution. So we have tan inverse sine of v. So this is going to be tan of alpha. And tan of alpha is going to equal sine of alpha divided by cosine of alpha. So now we have, we want it to look like this, so you're going to have to force it. We know that we have sine of alpha in the numerator. We already know that equals v. So that's going to match up. But what I want to do is let, if I have cosine squared of alpha, and I know that equals 1 minus sine squared of alpha. So if I want to rewrite and substitute cosine, I square root both sides. All right, so that would give me cosine of alpha equals this. So that's what I'm going to write. So we're kind of forcing it a little bit to make it look like that. So sine squared of alpha. All right, so now we're going to simplify. We know that sine of alpha is v. Then we have the square root of 1 minus, and we have sine of alpha again. So that's v, but this time it's squared. So there you go. We showed that they do equal. Thank you. Have a nice day. Bye-bye.